Hey guys, how's it going? Well, as you can see by the beginning of the video, I got this compressor to run continuously and load and unload without shutting off, and I will show you how I did all that. And it's been a couple of years since we've last talked about this unit, and this panel here, the one that you see right here, is a piece of hardy board. The original panel succumbed to the elements. Basically, it just rusted to pieces. You can see the rest of the enclosure is really not in that great a shape either. It's from just sitting around in this damn climate more than anything. It's in really rough shape in a couple of these places. I'm gonna have to kind of get busy with some restoration here. I mean, even the fins on here have just been completely broken and just from the rust and whatnot, but it runs great. And let me take the covers off it, and we'll show you what I did to it. Okay, as you recall from the previous videos, the intake on this machine is, for all practical purposes, it's just a check valve. On any kind of rotary screw compressor, when you shut the unit off, the lubricant tries to come out of the intake. It's just everything wants to go backwards. A lot of machines have oil stop valves on them. The older machines do have oil stop valves on them, and a discharge check valve, like a discharge check valve that would go right in this line right here. Nowadays, most manufacturers are using a poppet style inlet valve, as they call it, and it does two things. It can either close or open or modulate, but the end result is it acts as a check valve. So this is what this machine was designed to be. Back when this thing was designed, it was supposed to be just a start-stop machine, and there is a blowdown valve or a vent valve that's located over here. Let's see if I can't get you a better view of that. Alright, this being the blowdown valve. This valve is normally open, and it's tied into the coil, the main motor starter coil. It's tied into there, and what it would essentially do is, when it starts up, the valve is then energized, it closes, and then when the machine shuts off, it becomes de-energizes and it vents the sump tank down so it won't start up under a load. That's just the basic way that they work in most cases, probably 99.9% of the time. But at any rate, so what I have done is I kind of banged my head around. I wanted to come up with a modulating inlet valve, but that didn't really seem like it was going to be easy to fashion on here. So then I thought, well, I wanted to use just what I had laying around. And I had this old 3/4 inch solenoid valve here, which is normally open. That's the characteristic of the valve. It has a rubber diaphragm inside of it, and I was concerned about down the line if something were to happen to the solenoid valve, the rubber diaphragm. I don't know what the characteristics are of this valve under vacuum conditions, so I put a Y strainer in here. There's a screen inside there, so if something does malfunction or go bad, the screen will catch it and it won't go into the rotor cavity and destroy the pump itself. So that's what I've done there. Typically it would be nice if the blowdown valve was normally open, as it is, and it would be nice if the inlet valve, which this has now become, was normally closed. That way, if you shut the machine off, this closes. It goes back to its normal state, which is closed, and the blowdown valve goes back to its normal state, which is open, and it vents itself down. I didn't have the luxury of that because I was really trying to use parts. I didn't want to spend a lot of money on it. So I essentially tapped the inlet for 1/2 inch NPT thread, and there's not much meat there. You can tap it, but I ended up having to really use a pretty heavy-duty type of a Loctite to secure it. And then when you start hanging things off the end of it, as I have done here, it tends to pick up more vibration than it would normally have just if it was just mounted just right to the inlet as it was before. So I didn't really go through any extreme measures. As you can see, I just basically wire tied the intake to this position here. I cut a male adapter, cut the threads down, this male adapter, and just made it fit to the old intake filter. And then this is just PVC pipe, which there's no problem doing that. You don't want to use it for compressed air, you know, on the other side of things, the pressure side of things. But right here on the intake is perfectly fine. So like I was saying, so the intake valve would have been nicer had it been normally closed. So it's not. So I'll show you what I had to do to make all these things work correctly. I essentially added a pressure switch, as you can see down here. I added this Allen Bradley pressure switch. And let me go around to the other side over here. And then I've added this relay right here. Like I said, this is all things that I just had laying around here. This has got way many more contacts than what you need. So essentially what I'm doing is I'm using the pressure switch that you just seen to drive the relay to control the inlet valve and the blowdown valve, because they work ass backwards, and well, at least the intake valve does. The intake solenoid valve works ass backwards. So I'm essentially using this relay to mimic what I really wanted to do. So the pressure switch, which typically would be a normally closed situation, so it would be closed, and then the contacts would open on rise. This is working ass backwards. The contacts are closing on rise, then it operates, the actual pressure switch operates the coil on the relay here in between the normally opened and normally closed contacts that are on this relay. I'm able to get the valves to do what I want them to do, essentially. And then what I did is, to get the machine to run start-stop again, I essentially put a toggle switch in. Once again, it's a used toggle switch. The CR stands for continuous run. Below it, below it says start-stop, SS. So that's what that is. And what this switch is, all it does is just disconnect the control power to the pressure switch that you see that I added on. So when we do that, we then go back to the way the machine was built. Now it's going to operate off of its original pressure switch and run start-stop. And that is essentially what I've done. I'm going to button this up and then run it for you. You might be able to hear it. I don't know how well this camera is going to pick up the actual audible sound of the compressor loading and maybe even it venting. I can actually take the vent line off here. Maybe you might even be able to hear it a little bit better. I could remove the vent line. This is the way it came. It was just kind of wedged in here in an Atlas Copco fashion. So that is what I've come up with. I think it's going to be a good running unit. I really can't see anything really going wrong except for maybe the intake valve, and I really don't know that that's a harsh environment for it. I don't know if they're rated for vacuum though, so although it seems to work fine. The only other issue that could be a problem is, typically on a rotary screw compressor, you want to try to achieve some sort of an unloaded sump pressure. That means that when the compressor does unload, when the inlet does close, and you vent the sump tank down, you want to have some residual sump pressure to try to move the lubricant. And I don't really know what the unloaded sump pressure is here. It seems to be moving a little bit of air, although I don't exactly know where it comes from. In some compressors, when you slam the inlet, they have a problem called rotor rumble, and it gets quite excessive in some manufacturers. And in some cases, what they'll actually do is put a check valve right in this line. They'll put a line right here that runs from here all the way back around over to here with a check valve in this line here. And what it essentially does, with a small orifice or something of that nature, depending on what size the machine is, and it will recirculate air as that valve is closed to try to keep the rotor rumble or the rotor knock to a minimum. This machine, like I said, doesn't seem to achieve that, or doesn't have that problem as far as the noise goes. And I have seen some new vacuum pumps lately in the rotary screw version that have had which typically have an oil pump on them. to achieve their oil flow, and I've seen a couple that haven't even had any oil pumps on. So I think they've realized that an oil pump may not really be needed, and I'm going to roll the dice. The only other thing I could do is on the vent line itself down below there, if you can see that vent line itself right there, I could actually tap off that and throttle it back, or maybe put an orifice in there, but I'm really not concerned. It seems to be just fine. I've run it quite a bit. So anyway, let me button it up and we'll run it again. Well, one downside to the man cave is it gets really noisy in here when it rains, and that's what's going on now. Who says the sun doesn't shine when it's raining? Alright, well, she's finally stopped raining. Didn't take long. Alright, well, I got this plumbed into the Quincy, which is outside, so let's go ahead and crank it up. Now if I switch it to start-stop, switch it back, it just goes right back to the original setting of the pressure switch that was installed. Back, it loads back up again, and it should shut off here real soon. I think it's set for about 120 pounds, just a little bit higher than the pressure switch, the Allen Bradley pressure switch I added. There she goes. And then on falling air pressure, it's going to restart again. I'll create a little bit of a leak outside and get back in here, and then you can see it start back up again, I guess. Alright, it should start just about at just a little bit under 100 psi. And that's going to be working off of this original factory pressure switch right there. So it'd just be a couple seconds here. It'd just be low. You can probably hear the outside leak. And right around, I don't know, I think it's probably about 95 pounds. She'll start just under 100 here on the gauge. See what the amperage max out at when we run start stop. I know it's going to be high, probably maybe an amp high. Let's see here. Definitely over amperage on the start stop mode by just a little bit, but I think I'm going to leave it like that. And then before I had the switch, I had this in the wrong position. In the continuous mode I had it start stop. I wanted to actually see what the actual current was running continuously. But I think it's just right at, I think it's just like right at 15 amps. Before I even threw the switch and it unloaded, so it was right at 15 amps. So it should work good. Put the cover back on it and I turned the air conditioner off so you could hear as much as you possibly could as far as the unit loading and unloading and venting and whatnot. But that should pretty much complete this whole rotary screw project for right now. A few things I got to tidy up. One thing I definitely need to do is mount this. I can't just leave this hanging in here. And the other thing I need to do is this right here feeds the whole thing. It comes right off the bottom of the contactor to pick up the single phase. Well, actually, not single phase. It's to pick up the 110. And there's no fuse on here. And this goes right to the coil on the solenoid valve for the inlet. So definitely need to get a fuse on there. And mount this back over here for starters. Alright, well I got the cover back on. I actually put a hole in it. Right in there. And so I guess that's going to conclude it, guys. It's awfully nice and quiet compared to a damn piston compressor, I'll tell you what. I mean, you can hear yourself think, you can talk around it, no big deal. Should unload here any second, just for the final old test here.